today we will talk about Earth that is visible, how it is visible from space, and we will see what information can we obtain from satellite images. And yeah, so basically satellite imagery belongs to remote sensing, and remote sensing is obtaining information about any object without physical contact with it. So, for example, if we measure temperature with a thermometer of the water, this is direct measurement. But if we measure temperature of upper atmosphere and we are not there, then it's remote sensing. And the largest program using satellites to take images of Earth started in 1972, and it's still operating. It's called Landsat, for example. There are many other satellites doing research on Earth, but this Landsat, for example, you have here images obtained by it. So as you can see, there are many different kinds of information that we can get out of such image. And what is the difference between image and photograph? So the photograph is registering reflected light, visible part of the light, while image can also record other wavelengths, other part of light that we would not be able to see, and then it assigns some colors to highlight some different properties. So, for example, if you wanted to trick a satellite and you would put some big piece of material that would be colored in dark blue. So in a satellite photography, it would appear as, for example, a lake or something like this. So we could think that there is a lake on the surface. But if you do the same area image with different part of light, for example, in infrared, then because the water absorbs infrared, then on infrared it would appear black. And if we are comparing this, then you cannot trick satellite images, because then you will detect that it's not water, it's not lake, because on different image it would appear in different colors. So this is one type of comparing information to obtain some additional properties. And for example, here is an image in infrared, actually, and the color that is assigned to brightest things in infrared is red. So the objects that are reflecting the biggest amount of infrared waves are colored pink red. And by looking at this image, we can, for example, detect how well shaped is a plantation, because vegetation strongly reflects infrared light. And in the upper corner you can see this is image of one of ice shelves in Antarctica, and you can obtain some information on the conditions, like is it going to collapse, or is it sea ice, or is it ice shelf, and based on this you can kind of get information on areas that would not be easily accessible otherwise. So this is an example of usage, but here on this images you have surface of Earth, but we can also do some measurements of the atmosphere, and such example includes temperature. There are no direct temperature measurements of the atmosphere, like upper atmosphere, but based on satellite measurements, we can globally model this temperature changes. And here is an example. This is based on anomaly. So it compares temperature that occurred in February last year with average value of temperature. With average temperature between 1951 and 1980. So it gives a good coverage of observations. Otherwise, we would have only temperature recordings from observation stations on ground. And for example, this would be higher in the northern hemisphere, as we have most of the stations located there. So this is a good indication of how this temperature is changing globally. And here, for example, well, February is basically one of the coldest months usually. And here, comparing to the average temperature of each of these areas in the period between 51 and 80, we can see some changes. And the highest changes are occurring in the northern hemisphere, in the Arctic region, where it's a positive change, so the temperatures are increasing generally, because of course there are some places where these changes are negative, and there is a negative trend in most of Antarctica, in most of the area of Antarctica. But of course, it's also there are some signals of positive change, for example, in Antarctic Peninsula. But anyway, this is something we can use to obtain more detailed information. And well, temperature change is basically connected to climate change. So by checking average global temperatures, we can determine some global general trend. And there might be breaking news on the internet or newspapers about some different trends that, even though the most of scientists believe that there is a increase, there is a global climate change, positive global climate change. Some may say that there is no such thing because, for example, there is a negative temperature change in some area. But this, well, this is very complicated because of the different conditions like winds, changing patterns. So any change in temperature distribution will change some global patterns in or local conditions. So even though there might be areas where this temperature increases, there will be also areas that where this temperature is decreasing. And one of things that are usually talked about regarding climate change is carbon dioxide. And this is closely related not only to natural sources like volcanic eruptions, but also to human activity, because, well, as we are burning fossil fuels, we are emitting carbon dioxide. And well, here you can see these are direct measurements, and this is based on ice core samples from Antarctica, and we can see a very steep increase in the carbon dioxide level after 1950. So we already exceeded the level that was occurring, that was maximum during the last 400,000 years. And now we are improving this kind of measurements of carbon dioxide by taking satellite measurements. And this is done because this is done in this way that it's measuring the amount of light that is reflected from the Earth's surface. So basically it goes twice through this layer where there is carbon dioxide, and changes in this reflection is connected to changes in carbon dioxide amount. So now these measurements are improved, and the aim is to get more information on where exactly it is created and where is it going and how fast it's traveling and so on. So nowadays we are increasing number of observations to get more detailed model of carbon dioxide effect on our planet. Okay, if you go to our to the website of our project of EDU-ARCTIC project, you will see the sea ice concentration graph, and this is also based on satellite measurements. And how this is done is that satellite, as it is traveling on its orbit, it collects information on each pixel, and pixel is representing some area on the Earth's surface. And because ice has different properties, reflection properties than water, we can distinguish ice from water on the sea. So by measuring these reflective properties, we can get some information on where this sea ice is concentrated. And this is an example of such graph. And well, there are many units observing this. This one is from Institute of Environmental Physics in Germany. And so these observations can be done daily, for example. And then if we get such observations daily, we can calculate some average over months, and then we can calculate some average over year, and then we can detect some general trend of how this sea ice is changing. So we will take a look at now at real life data. So as I mentioned at the beginning, you got some numbers assigned to your school. So if you could go to the link that that should be provided, then you will be able to work on the file. You should have something like this. So if you open this document, you will have observations, and this is real life data from satellite measurements, which started in 1979. So the satellite was collecting daily, monthly data, and this is a record of sea ice extent, and the unit here is millions of square kilometers. So, for example, in January 1979, the sea ice in the Arctic region had extent of 15.6 millions of square kilometers. Now, these are just some observations, and what can be done. Oh, by the way, because if you want to work so that everyone in one school works on different document, and maybe you should copy this and create the new spreadsheet. So So you will not all work on one spreadsheet. So how to do it? You just, well, the easiest way is just click somewhere on the spreadsheet, then Control A. So it's to just to mark all the observations. Now you should use this plus sign here to add another sheet, and then in A1, click on A1, and you can either just paste. Well, okay, I created different thing, but yeah, copy. I forgot to copy. Control C is to copy this document, and now you put it in A1. Control plus V. So it would be like this. So now you have in one document you have different sheets, so everyone can do this and work on different sheets to have separate results. Otherwise, you would be all working on the same file. So, well, you could also do this, but then it would be more complicated. So, if let's say you have 10 people in the class, just please create 10 of such sheets and copy data into each sheet, so you can work on it independently. If there is someone who has number 1, then you would work on this file as I1, and you can copy these observations into another file here, and so that if you have 10 people in a class, you can get 10 documents. Okay, but going back, because I work on my file alone, so you can see everything. This is my document. And what we want to do is that we have some observations, but I mean, looking at numbers, just numbers, we don't really see anything. So the first thing we will do is to plot this data to see some general trend. But I marked here the boundary on 1998 because, as you can see, we have some blank fields. So we will use just data after 1989, and we could use the previous data, but then we would have to kind of change properties here. Anyway, so everything we will do on the data after 1989. So if you want to plot such data, then you need, well, first of all, these are monthly changes. So what we are trying to calculate will be how Arctic sea ice is changing throughout years. So we will calculate the change per year. And to calculate the change per year, we have to kind of first calculate the yearly averages. And we are using averages in everyday life, and you may not even think about it. But for example, if you try to share something with others, and let's say some has, I don't know, 4 euros, and another person has 2 euros, so on average you have 3 euros per person, right? So what you did was to add the money that you have and divide it by the number of people. So here we are doing the same. So we are adding the whole observations for 1 year for each month, and we will divide it by 12 to get average sea ice extent during the different years. So let's create here in N column, it will be the sum, and we are doing it by typing equal sign and then sum. It's a function to sum the observations, and we mark now the extent. So we are summing everything in 1989, so from January until December we are adding these observations. And yeah, you have to have brackets to have it. And now you press enter and nothing is appearing. Yeah, okay, now it works. So this is the sum of all observations from 1989. Generally, you need to sum all these observations in this cell here. So I will delete it and do it once again so you can follow. So clicking on the cell that we want to have the result in, we are putting equal sign, type sum, and now the bracket. And now we are marking the area that we want to calculate the sum of. So it will be like this. And now we need to close the bracket. So the formula that needs to be written here is like this. And when we have such formula, we press enter. Right now I have only one such sum, and there is a very nice trick in such documents like Excel or here Google, that you can automatically expand this. So you click on the cell with your sum, and now you have some square in lower right corner. And if you click on this and you move the cursor down, you're extending this formula. And automatically the sum of each year is calculated. So you don't need to do it. You don't need to do it manually. So this is very useful. And well, now if you go to any kind of cell, you have the same formula that you typed at the beginning, just it's automatically converted to another line. So you have sum of each observations in each year. So now we will calculate the average sea ice extent during the whole year. So during the whole year we have 12 months, so we are dividing this sum with 12. So again, to type any formula in this, we always start with sign of equal. So equal, and now we click on the cell containing the sum, and we divide it by 12. And enter. And we already have the result of average sea ice extent during 1989. And now the same trick as with calculating the sum. If you click on this cell, you have this square in lower right corner, and if you click on it and drag it downwards, you will get averages of each year. So every year you have the sum of all observations, and every year you have the sum divided by 12, so you get the average value of sea ice extent during such year. Okay, you have some results. I can see. Okay, you used a different function. This is also another way of calculating it. You can directly use this average function. I just wanted to show you how average is calculated. So in case you're using average, you don't really need to use the sum function here. But yeah, it's good you use this function. You see it. Now what is this is good because you have, if you do the I hope this is not taking into account this value here, because otherwise you will have the number, if you put averages, it's until m. So here it may be assigned 0, so then the average would be a bit distorted. This is, yeah, you can use such function. And yeah, so you can either work on the whole data set, or you can use the set after 1999, as I suggested. Well, it depends. If you are using this average function, then you can use the whole data set. If you're using it manually, like sum and divide it by 12, you would have to divide it by 11 in this calculations, and not mark these cells that are empty. So it's up to you. I think it's more simple to just use data after 1989 because it's a lot of observations anyway. And okay, so now you have some average values, and now we want to plot it. You have to mark your observations, so the average observations, and insert chart. So insert chart, and you get some type of chart, right? And now you can see some downward trend of these observations. So we can already say, by looking at it, that there are some small fluctuations in sea ice extent throughout between years, but generally it appears to decrease in extent. And how to calculate this average decrease in extent? You can use function. Well, normally, if you used Excel, it would be more straightforward because you would just click on the chart, and you would add the trend line, and you would have automatically it here. But to be honest, I haven't used this spreadsheet before, so I didn't find the trend line option here. It should be somewhere. But there is another way of doing it, and we can calculate it. So we will use formula, and it's lean est. This is estimation of the trend based on observations. So if you write lean est and mark your average values, now you put comma and you add years. You don't need to add years. You could just probably use only these observations because we have constant time period between observations. And now what we got here are estimates of linear trend. So this is change. Negative is because it's decreasing. We don't need to look at this coefficient. It's in a line equation. It corresponds to intersection of this line with 0 value. So it would correspond what would be the sea ice extent in 0 year, let's say, but we don't want to have it. But we are looking at this coefficient because it describes how fast sea ice is decreasing. And you remember that I said the unit here was millions of square kilometers. So this corresponds to yearly change, and it means that if that was a million, then we have a decrease of 62,000 square kilometers per year, right? It's just changing the units. And so if you were using more data from previous years, you would probably get this value different. It would be probably something, well, some smaller rate of decrease, because the sea ice extent in those years at the beginning, it was decreasing less rapidly. So now, by using the most recent data, we will have faster decrease, which means that the rate of change is in sea ice extent is basically changing. So by this exercise, I just wanted to show you that even with such simple calculations, because it was just to calculate average yearly observations and determining the trend line of it, we can already say something about the sea ice, Arctic sea ice extent changes. And if you're interested, you could do the same calculations for Antarctica, but you would have to download the data from the NASA website. They are open, so you can download any data and do the same things. What will be interesting is that for Antarctica, you will see the increase in sea ice extent, and this is in agreement with those temperature changes that I showed you, that in Antarctica generally the temperature is decreasing. So so that would be funny to see. Anyway, because this is one of comments on of global changes, like skeptics. If you compare the value of rate of decrease of sea ice in the Arctic, you will see that it's way much more of sea ice decreasing in Arctic than there is an increase in Antarctic. So the overall change of sea ice is negative. I hope you managed to do this. Okay, yes, there are different. You can change the type of chart here, because apparently this is yeah, you plotted some here probably, and yes, there is a chart type of linear. So I would suggest to change it. But generally, from this chart, you can also see some trends. Okay, because we are running out of time, well, you already see how to create such thing. And you can work on it. So I guess it will be all for today, and thank you for participating.